This video is for class 8 physics and we are discussing effects of refraction. The first effect of refraction is the depth of water in a vessel when seen from air appears to be less. So consider a vessel containing water as shown in figure 5.6. Its real depth AO, but when seen obliquely, that is at an angle above O from air, its depth appears to be AI, which is less than AO. So this basically tells us about the effect of refraction, where the bottom of any tank or any glass containing water will appear to be raised little bit up. So going to the next column, here you can see one diagram, right? So that is the apparent depth of the vessel full of water. Apparent depth, so real depth, first thing let us understand what real depth is. This is the real depth, that is from the surface of the water to the bottom of the container, whereas this here is the apparent depth, right? So why does this happen is, now as you can see, when the bottom part of the vessel, that is O, throws light, it can throw any number of light, okay? So but for simplicity we have taken two lights, they are this and this. So when a ray of light strikes the surface of separation here, as you all know, now it is moving from denser medium to the rarer medium, therefore it will bend away from the normal, right? So it is bending away from the normal. And as you all know, when a ray strikes the surface of separation such that the angle of incidence is 0 degree, or it makes 90 degree with the surface of separation, then there is no refraction of light and the rays the ray will go straight out, okay? So when I produce this particular ray backwards, okay, it will join at this point, right? So the image of the bottom of the container is formed here at this point. Similarly at this point, for this point the bottom of the container will be, the image of the bottom of the container will be formed here, and at this point the image of the bottom of the container will be formed here. Suppose we take different points of the bottom of the container, then we can have different points of the image also, but for the simplicity we have just taken one point, thus which is enough to explain that the object has shifted, right? And this particular distance is known as shift. This particular distance is known as shift. So I hope you have understood the reason also. It is because of the refraction of light. It is because of the refraction of light. So going to this blue box, do you know box? So this is the third formula for refractive index, which is real depth by apparent depth. Real depth by apparent depth, as I have shown you all in the figure. So we had total three formulas for refractive index. This was the first one, which was sin I upon sin R, right? Now the other one was mu equals to this mu, if you remember, it is refractive index, is the speed of a light in the medium 1 divided by speed of light in the medium 2, and this one here is the third one. Since the refractive index of water is 4/3, so the apparent depth will be just reverse of that, which is 3 upon 4 of the real depth. This is just for your information, right? So now going to the next topic. So here you can see the bending of pencil at the surface of separation. Here this is the surface of separation, right? And here you can see the bending of the pencil here also, right? So this is all because of the refraction of light. Actually what happens is, like the previous drawing, okay, a ray of light can be taken, okay, which moves up outward, and another ray can be taken in any direction, for example at this direction, right? And thus what will happen, if I draw a normal here, it will bend towards it will bend away from the normal. Thus when we try to bring it back, okay, at this point, so the pencil will appear bended here, right? So I hope this is understood. Okay, so going to the next topic again, which is early sunrise and late sunset. Sorry, which is early sunrise and late sunset. So before sunrise and after sunset, the upper atmospheric layers are warmer and the layers near the earth's surface, okay, compared to the layers of the atmosphere near the earth's surface. So the atmospheric layers near the earth's surface will act as a denser medium because it is colder than those above it. So when the sun is just below the horizon, the light from the sun while coming towards the earth's surface suffers refraction from a rarer medium to a denser medium. So it bends towards the normal at each refraction. So due to continuous bending of light rays at different successive layers, suppose we consider different layers of atmosphere, then the sun, okay, can be seen even when its actual position is just below the horizon, as shown in the figure 5.9. As a result, sun is seen in advance a few minutes before it rises above the horizon in the morning. Similarly, in the evening, sun is seen delayed by 3 to 4 minutes longer above the horizon after the sunset also. So let us try to understand this particular thing with the help of this particular diagram here. So this is the actual position, real position of the sun, actual position of the sun. So here if I consider this particular ray which is going up and strikes the surface of separation, this is the vacuum here, right, this is the vacuum here, and this is air, okay. So here it strikes from the rarer medium to the denser medium first, okay. So the particular rays should bend towards normal, but as the paragraph says that this portion of the atmosphere is much more colder compared to this portion here, right, when the sun is at this position. So every time the ray is bending towards the normal. Thus when we consider the ray of bending of the ray, right, so here you can see here at this position here it bends towards normal, so it bends a little bit downwards. So when I produce this backwards, so the sun appears to be above the horizon. This is the apparent position of the sun. So if the observer is here, he or she will see the sun here rather than here because of the refraction of light. So I hope this is clear. Okay, this much for this video. Thank you so much.